Thank you so much, Brian, for these very kind words. And thank you so much to the Hope Funds for Cancer Research for this award and for the tremendous work that you do. Like Janet, I feel this award is not just awarding me. I really want to thank my teachers, my mentors, and in more recent years, the wonderful colleagues in research, my trainees, my members of my research team, and my collaborators, because really it's their work, I feel, that's being recognized. Our work together. Really, we've had such tremendously good times working together, and I feel this award today truly honors them as well. Now, my research on telomeres, as Brian mentioned, and how they're replenished, truly was very basic, question-driven research. It was not directed at cancer per se. It was really about how does nature work? And it's turned out to have ramifications for human health and diseases, and including particularly the scourge of the mini cancers that we still are needing to tackle. We found that telomeres, the ends of chromosomes, are special. They're specialized DNA, they're special proteins. They protect the chromosome ends from damage, but without intervention from the enzyme telomerase, they gradually erode away over the years of our lives, and that can now put cells in danger of malfunctioning or of death or of even turning into cancer cells. And so this shortening process then impacts on our ability of our bodies to keep replenishing over our lifespans. This is what it's now turning out to look like is going on. So can the shortening be prevented, slowed, or even reversed? We can dream. It can in the test tube, perhaps maybe who knows, in people. And I think that's what science is about and why we encourage young imaginative fellows, as the Hope Funds for Cancer Research does, to think of exciting possible dreams. Can we use the enzyme telomerase to turn the clock back and stop the ticking down of the ends of the chromosomes, which then makes cells susceptible to becoming, among other things, cancerous? Cancer also has too much telomerase. In the wrong setting of the many things that happen in cancer cells, telomerase becomes overly active. And so that is another avenue one can start to dream that this might be a way of one of the many ways of attacking cancers. But in the happier setting of normal cells, the maintenance of the chromosome ends by telomerase is good news, and we want to understand how it can be shortened, because indeed in humans it's now emerging that shortening is linked to processes that really go on in aging, including propensities for cancers as we age. And so I really think that we can start to think about now, how can we reverse or slow this process down, and in ways that may end up having impact on something which has been much harder. How do we think about actually preventing cancer? How do we preempt it, stop it in its tracks before it becomes cancers? I think it's now the science is moving to the point where we can really start to dream about that question. So, and dream about acting in rational scientific ways in terms of attacking cancer at its roots. The best thing would be for there to be no need for Hope Funds for Cancer Research. So much of that, I would hate to see the end of this wonderful entity. But the last thing I want to say is just to go a little bit beyond the very important topic of cancer research, and that is, I think, the recognitions we're getting for our work this evening among the four of us are really honoring more than just the work of individuals, because I think it's in honoring our research, what the Hope Funds, I think, is awarding and honoring is something broader and of broader symbolics and real importance, and that is a human desire and quest for knowledge and understanding of the natural world, and that desire and quest to turn that into human betterment. So I want to thank again the Hope Funds for this wonderful recognition and for the terrific work that you do.